Hello everyone, this is Sir Brian Orlason Cordova and welcome back to another calculus class, and today's topic is about triple integrals. So kagaya noong ating napag-aralan sa double integrals, so the triple integrals over a rectangular box, define yung rectangular box by its coordinates, and so given the domain of the box, x, y, z, where x is from A to B, y is C to D, and z is R to S. So, ito yung figure ng rectangular box. And it is subdivided into smaller sub-boxes with equal widths. So, yung widths ng delta x, delta y, delta z, so along the major axis. So, each sub-boxes has volume of delta v. So, the product of each dimensions ng sub-boxes b sub I, j, k. Okay, so we can form a triple Riemann sum kagaya na ginagawa natin sa double integrals. So this triple Riemann sum of f of xyz sub ijk asterisk, these are sample points on each of the sub boxes times delta v, which is the increment of the volume of each sub boxes, and yung division kung ilan man yung sub boxes na meron ka, that is yung L, M, tsaka n. So definition, the triple integral of the function f over the box B is the limit of the triple Riemann sum as L, M, and n approaches infinity. Ibig sabihin, kung dumadami yung subdivisions mo, so papalit ng papaliit yung volume mo and nagiging precise yung evaluation ng triple integral. Okay? And as long as this limit exists. Okay, so just like in Fubini's theorem sa double integral, so if the function f is continuous on the rectangular box B, so yung B is having a dimension A to B by C to D by R to S, then the triple integral of the function of xyz dv on the rectangular box B is the iterated integral of the function of xyz dx, dy, dz, where x is evaluated from A to B, y is evaluated from C to D, and z is evaluated from R to S. For example, evaluate the triple integral of xyz squared dv, where B is the rectangular box given by this definition. It is the ordered triple where your x is from 0 to 1, y is from negative 1 to 2, z is from 0 to 3. As a solution, we could use any of the 6 possible order of integration. If we choose to integrate with respect to x, then y, and then z, we could obtain this iteration. So the triple integral of xyz squared dv is equal to the iterated integral of xyz squared dx, dy, dz, evaluated from 0 to 1 yung x, yung y is negative 1 to 2, and z is from 0 to 3. So performing the inner integral, we have x squared y z squared. So in terms of x, so mag-i-square yung x and kakaroon ng over 2. So as x is equal to 0 and 1, so and substituting the a values of x, we have yz squared na lang over 2 dy dz. Okay, then evaluating the middle integral, we have y squared z squared over 4 since it focuses on the variable y. So evaluated from negative 1 to 2. So it is equal to the integral of 3z squared over 4 dz evaluated from 0 to 3. So performing that, we have z squared over 4. Then substitute 0 and 3 dun sa variable z, we have 27 over 4. So triple integrals over a general bounded region, just like in the general bounded region of double integrals. So meron tayong tatawaging type 1 solid region. So a solid region is said to be type 1 if it lies between the graphs of two continuous functions of x and y. So we have the functions u sub 1 of xy and u sub 2 of xy. So the surface is from top to bottom. That is, E is the ordered triple XYZ where your X and Y ay elements of the region D, which is the projection ng solid region about the XY plane. And Z is inside two functions of XY. We have U sub 1 of XY and U sub 2 of XY. So the upper boundary of the solid E is the surface equation Z is equal to U sub 2 of XY, while the lower boundary of the solid E is the surface equation Z is equal to U sub 1 XY. So the triple integral of the function of x, y, z dv on the solid region E is the double integral of the integral of f of x, y, z dz. So z is evaluated from these two surface equation, and dA, which is the area of the projection onto the xy plane. Okay, so type 1 solid region. So, meron tayong type 1 solid region with type 1 plane region. So, ang plane region natin ay type 1. Remember, dun sa ating double integrals, we have plane type 1 and type 2 plane regions, where yung type 1 plane region is bounded by the functions of x. We have g sub 1 of x and g sub 2 of x. Okay, so the triple integral of the f of x, y, z dv is ito. So z is evaluated from the functions of u sub 1 of xy, u sub 2 of xy, and yung y is evaluated from the functions of x. So g sub 1 and g sub 2 of x. And the x is from the interval a to b. So meron din tayong type 1 solid region with type 2 projection. So, ganun pa rin, yung z is evaluated from the functions of xy, but yung projection d on the xy plane is bounded by functions of y. So, we have h sub 1 of y and h sub 2 of y. And yung y is from the interval c to d. So, the integral is the triple integral of f of xyz dz dx dy. So, mag-change lang yung order dito, where yung x is from h sub 1 to h sub 2 of y, and y is from the interval c to d. So as an example, evaluate the triple integral of z dv on the region E, where E is a solid tetrahedron bounded by the four planes, x is equal to 0, y is equal to 0, z is equal to 0. And x plus y plus z is equal to 1. So, solution, first we can draw diagrams nung solid region and yung projection niya onto the xy plane. So, ito yung itsura ng solid tetrahedron. So, we have this red face is the x is equal to 0. So, yung x natin is a vertical plane. Y is equal to 0. So, vertical plane din siya along the y-axis. And z is equal to 0 is a horizontal plane onto the xy plane. And x plus y plus z is equal to 1. So that is a face na pwede nating i-change into a function of xy. So we have z is equal to 1 minus x minus y. Okay. So the solid E is evaluated from these domains. So x is from 0 to 1. So we have 0 to 1. And y is from 0 to 1 minus x. So, 0 to 1 minus x. Dahil dito manggagaling yun. So, for x plus y plus z is equal to 1. So, yung plane surface na to. For z is equal to 0, so yung line na to would be the boundary x plus y is equal to 1. So, ito yung magiging projection dun sa xy plane. So, y would be evaluated from y is equal to 0 hanggang sa y is equal to 1 minus x. And this equation is from this one. So, transpose lang natin yung x para makuha yung y is equal to 1 minus x. Yun yung upper bound ng values of y. And yung z is evaluated from z is equal to 0 up to the one of the faces where z is equal to 1 minus x minus y. So, yun. Okay? So the triple integral of z dv is equal to z dz dy dx. So yung limit ng z is from 0 to 1 minus x minus y, and y is from 0 to 1 minus x, and x is from 0 to 1. So we have z squared over 2, where z is equal to 1 minus x minus y raised to 2. So mayroon na tayong 1/2 doon. And performing again the next integral, we have 1 minus x quantity cube dx, then 1 over 6 na siya. Performing the last integral, this will become 1 over 24. So the value of the triple integral of z dv, where E is a solid tetrahedron bounded by these 4 planes, is equal to 1 over 24. So meron din tayong type 2 solid region. So a type 2 solid region E is said to be type 2 in the form E, where yung YZ is element ng D, where yung D natin is a projection, this time, onto the YZ plane. So YZ plane. And the back surface of the solid is x is equal to u sub 1 of YZ, while the front is x is equal to u sub 2 YZ. Then we have the triple integral is equal to double integral of the integral of f of xyz dx, where x is evaluated from u sub 1 to u sub 2, so functions of yz, times dA, the derivative of the area of the projection D onto the YZ plane. Type 3 solid region naman is almost the same, pero this time, ang projection D is onto the XZ plane. So type 1 is onto the XY plane, type 2 is YZ plane, type 3 is XZ plane. And the surface are functions of XZ. So y is equal to u sub 2 of xz, and y is equal to u sub 1 of xz. So yung triple integral would be evaluated where your innermost integral would be integral of f of xyz dy, where y is from u sub 1 up to u sub 2, and the area is the area of the projection D onto the xz plane. Example. So let's evaluate the triple integral of the square root of x squared plus z squared dv, where E is the region bounded by the paraboloid y is equal to x squared plus z squared, and the plane y is equal to 4. So ito siya. So yung paraboloid ay ito, yung pinaka-shell. And yung plane y is equal to 4 is itong circle na to. So as a solution, so yung E would be ordered triple where x, y, z. So yung x is from negative 2 to positive 2 because at y is equal to 4 and z is equal to 0, ang magiging values ng x would be negative 2 up to positive 2. And yung y is from the parabola y is equal to x squared up to the plane y is equal to 4. And yung z natin is from negative square root of y minus x squared up to positive square root of y minus x squared. So, nanggaling yun dito sa equation of the paraboloid when we solve for z. So, if we regard it as type 1 region, so i-consider natin yung projection niya na d sub 1 onto the xy plane. So, along the xy plane, ito yung projection niya. And that region is bounded by y is equal to x squared, so parabola, up to y is equal to 4. So yung plane na y is equal to 4. So the triple integral of the given function square root of x squared plus z squared dv would become like this. Okay? Although this expression is correct, it is extremely difficult to evaluate. So dahil puro square root. So pag nag-substitute pa tayo, so magkakaroon ng stacks of square roots. So let's consider other type of region. So from here, mas madaling i-consider yung projection d sub 3 onto the xz plane. So given this, So, ang projection niya is the disk x squared plus z squared less than or equal to 4. Since yung points ng xz would be inside the circle x squared plus z squared is equal to 4. So, pwede siyang less than to 4. So, andito yung mga points. So, ito yung projection niya, yung disk. And itong boundary would be the equation of the circle x squared plus z squared is equal to 4. So, the left boundary of E is y is equal to x squared plus z squared, which is the paraboloid. And the right boundary is the plane y is equal to 4. So, the triple integral of the function x square root of x squared plus z squared dv on E is equal to the double integral of the integral of square root of x squared plus z squared dy, where yung y is evaluated from the paraboloid y is equal to x squared plus z squared up to the plane y is equal to 4. And dA, where yung d3 is the projection d3, so yung this na x squared plus z squared plus is equal to 4. So, performing the integral dun sa gitna, so dito, medyo mahirapan pa rin tayo because of the form of the function. Although this integral could be written as this, pag kinuha natin yung limits nung dalawa pang integral, so medyo madiwara na, so mahirap na natin i-perform. It is easier to convert to polar coordinates in the xz plane, where gagamitin natin yung values ng x is equal to r cosine theta, and sa halip na y, since nasa xz plane tayo, z is equal to r sine theta. So we have the x and z axis. So from here, the triple integral of the original function square root of x squared plus z squared dv, which is equal to this expression, is equal to the double integral of 4 minus r squared, because minus x squared plus z squared is r squared because of the polar coordinates. Okay, so this is minus r squared. And yung square root of x squared plus z squared is actually r. And dA would be r dr d theta. And yung r is evaluated from 0 to 2. So distance ng any point inside the disk is from 0 to 2. And yung theta is from 0 up to a complete rotation 2 pi. So mas simple na ang kalalabasang functions. So we can simplify this. We have the integral of d theta. Pwede natin paghiwalayin since ito ay separate factors, times the integral of 4r squared minus r to the 4th dr, since yung dalawang r dito ay dinistribute na sa 4 minus r squared. So performing the integrals, we have 2 pi times 4r cubed over 3 minus r raised to 5 over 5, evaluated from 0 to 2. So this is equal to 128 pi over 15. So this is the triple integral of square root of x squared plus z squared dv, evaluated on the solid region E. So other applications of triple integrals, we have the volume. So recall lang natin that given the function f of x which is greater than or equal to 0, then the integral of f of x dx evaluated from a to b represents the area under the curve of y is equal to f of x evaluated from a to b. And if f of xy, so two variables xy, is greater than or equal to 0, then the double integral of the function of xy dA represents the volume under the surface of z is equal to f of xy and above the surface d. But the triple integral of the function of xyz dv, where the function f of xyz greater than or equal to 0, is the hypervolume of a four-dimensional object that is very difficult to visualize. Because dun sa double integral of a function, volume na yung nire-represent natin, and the triple integral of a given function is four-dimensional na. So hindi lang siya 3-dimensional kundi a 4-dimensional object. So it is called hypervolume. So it can be interpreted in many ways depending on the interpretation of the variables x, y, z and the function f of x, y, z. So a special case where the function x, y, z is equal to 1. So for all points on the solid E, then the triple integral represents the volume of E. Okay? So the volume of E is equal to triple integral of dv, where your function is equal to 1, and domain is E itself. Example. So find the volume T of the tetrahedron bounded by the planes x plus 2y plus z is equal to 2, x is equal to 2y, x is equal to 0, and z is equal to 0. So solution. So the tetrahedron T and its projection D on the xy plane are shown. So, in example natin to sa double integrals. So, yung surfaces ay, itong nasa ilalim is the z is equal to 0. So, yung nasa likod ay x is equal to 0. So, itong nasa harapang surface is x is equal to 2y. And itong face na to is the x plus 2y plus z is equal to 2. So, yung lower boundary would be the plane z is equal to 0, and the upper boundary would be the plane x plus 2y plus z is equal to 2, or solve natin z in terms of a function of xy. So we have z is equal to 2 minus x minus 2y. So yung projection niya onto the xy plane would be this one. Therefore, we have the volume of the tetrahedron is equal to triple integral of dv evaluated on the solid region T. So it is the integral of dz dy dx. So yung z is from 0, z is equal to 0 up to 2 minus x minus 2y. And yung y is from x over 2 up to y is equal to 1 minus x over 2. And yung x is from 0 to 1. So evaluating the integral which was solved previously to be 1 over 3. Solve na natin siya dun sa example sa double integral. So other applications, so finding the mass of a solid object that occupies the region E with density function rho of x, y, z. So the mass is equal to the triple integral of the density function dv onto the solid region E. And moments about the 3-coordinate plane are the following. So we have the moment about yz plane. So the triple integral of x times the density function dv. Moment about xz plane is the triple integral of y density function dv. Moment about xy plane is equal to the triple integral z times the density function dv. So the center of mass that is located at the point x bar, y bar, z bar, where yung coordinates ay equal sa moments divided by the mass. If the density is constant, the center of the mass of solid is called the centroid of E. And moments of inertia about the 3-coordinate axis. So we have moment of inertia about the x-axis. So we have y squared plus z squared times the density function dv. So we have moment of inertia about y-axis. We have the triple integral of x squared plus z squared. So kung ano yung nawawalang variable, so yun yung axis niya. Okay? Same with inertia about z-axis. Other application is the joint density function of the 3 random variables x, y, z such that the probability that x, y, z lies inside the solid region E is the triple integral of the given function of x, y, z dv. In particular, the probability that the variable x is between a to b, y is between c to d, and z is between r to s. So it is the iterated triple integral of f of x, y, z, dz, dy, dx. So evaluated yung z, r to s, y is c to d, x is a to b. So the joint density function satisfies these two properties. So f of xyz is greater than or equal to 0 since it is a probability. And the triple integral of xyz dz dy dx, all variables are evaluated from negative infinity to positive infinity, that is equal to 1. It is the total probability. Example, find the center of the mass of a solid of a constant density that is bounded by the parabolic cylinder x is equal to y squared and the planes x is equal to z is equal to 0, and x is equal to 1. So, a solution, so ito yung figure niya. This surface is the z is equal to x, and itong rectangular face na to is x is equal to 1, and yung along the xy plane is z is equal to 0. And yung parabolic face nito is the x is equal to y squared. So, projection niya onto the xy plane is bounded by the parabola x is equal to y squared and x is equal to 1. So, yung E ay may domain na ganito. So, we have y is from negative 1 to positive 1. So, from here up to here. Since these points are 1, negative 1, and 1, 1. And x is from y squared, so mula doon sa parabola, up to the straight line x is equal to 1. And yung z is from 0, z is equal to 0, so yung xy plane up to z is equal to x. So up to x. So if the density function is a constant, so let's say rho lang din, then the mass is equal to the triple integral of the density function or constant density function rho dv. So we have rho dz dx dy, where yung z is from 0 to x is from y squared to 1, and dy is from negative 1 to 1. So evaluating the innermost integral, rho is constant, pwede natin ilabas yan sa harapan. So the integral of dz, where z is equal to x, we have x dx dy. And performing again the second integral, we have x squared over 2, where yung x is evaluated from y squared up to 1 dy. So that is 1 minus y to the fourth. So yung over 2 doon ay nilagay na natin sa constant multiple. So performing the last integral, so this integral is the same with this one, where yung limits ay hinati natin. So from negative 1 to 1, ginawa natin 0 to 1 na lang. So hinati natin yon, so magiging times 2 yung kailangan natin. So pag minultiply natin sa 2, makakancel out yung 2 over 2. So we have rho na lang. So performing this, we have rho times y minus y to the fifth over 5, evaluated from 0 to 1 na lang. This is equal to 4 rho over 5. So this is the mass. So since E and yung rho, or the constant density, is symmetric about the xz plane, so xz plane, so symmetric siya doon, the moment about xz plane is equal to 0. And therefore, y bar is equal to 0 also. Okay? So ang kukunin na lang natin, given that mass is 4 rho over 5 and y bar is equal to 0, kukunin na lang natin is x bar tsaka z bar. Okay? To get that, we need the moment about yz plane. It is the triple integral of x rho dv. So evaluating that, we have this. Performing the integrals, and we will get 4 rho over 7. And another moment na kailangan is moment about xy. So the triple integral is this one. So z naman yung ilalagay natin dito, x. So continuously performing the integrals. So this will become 2 rho over 7. The coordinates ng center of mass would be x bar, y bar, z bar, which is equal to moments na i-divide lang natin sa mass. Since y bar is equal to 0, so y coordinate would be 0. And 4 rho over 7 divided by 4 rho over 5 is equal to 5 over 7. Cancel out yung 4 rho. And 2 rho over 7 divided by 4 rho over 5 is 5 over 14. So this is the coordinate of the center of the mass of the solid. The next topic is about triple integrals in cylindrical and spherical coordinates.